Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.8. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.8. Find the value of voltage V0 in given below figure using nodal analysis technique. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 1 kilo ohm resistance that are labeled as V0 using nodal analysis technique. So without wasting time, let's proceed towards the solution. We know that in order to do nodal analysis of a network, we have to follow some steps. In first step, we have to count total number of nodes present in that network. In this scenario, there are total 4 number of nodes present. One of them is reference or ground node. Other 3 nodes will be utilized for the application of nodal analysis. And this network have 3 non-reference nodes, so it will have 3 node voltage equations. In second step, we have to label all node voltages. In this case, we have labeled this node voltage as V1, this node voltage V2 and this node voltage as V3. In third step, we have to assume and label all unknown branch currents along with their directions. In this scenario, we have assumed all these branch currents along with their directions highlighted in red color. Now we will apply Kirchoff's current law on this node to get first node voltage equation of this network. On this node, one current is entering while 3 currents are leaving. Entering current is taken with positive sign while leaving currents are taken with negative sign. We have to find these currents equations and replace these two currents variables with their respective equations. Current I1 will be equal to voltage across this 3 kilo ohm resistance divided by the value of resistance. So I1 will be equal to V1 divided by 3 kilo ohm. Similarly, current I2 will be equal to potential difference across this 6 kilo ohm resistance divided by the value of resistance. Direction of current I2 is from node V1 to V2. It is indicating that voltage at V1 will be on higher potential than voltage at V2. And voltage across this 6 kilo ohm resistance will be the potential difference of these two voltages. So current I2 will be equal to V1 minus V2 divided by 6 kilo ohm. Now in order to further solve this equation, we will multiply this equation on both sides with 6 kilo ohm. Product of 6 kilo ohm and 8 milliampere will result 48 volt. Here product of 6 kilo ohm will cancel out with 3 kilo ohm in denominator. Only 2 will left and that 2 will be multiplied with V1, so the value will become 2V1. Product of 6 kilo ohm will cancel out with 6 kilo ohm in denominator, only V1 minus V2 will left. And here product of 6 kilo ohm will multiply with 2 milliampere, it will become 12 volt. Now we will subtract 12 volt from 48 volt and open these brackets. The equation will become 36 volt minus 2V1. This minus will multiply with variables inside the brackets. Minus V1 plus V2 equal to 0. Now place this 36 volt on the other hand side of equal to separate it from variables and add minus V1 and minus 2V1 together. The equation will become minus 3V1 plus V2 equal to minus 36 volt. This equation cannot be further solved, so we will leave it for now and label this equation as equation A. This is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, one current is entering, that is I2, while two currents are leaving, I3 and I4, and both are taken with negative sign. In next step, we have to replace these currents with their respective equations. Current I2 is equal to V1 minus V2 divided by 6 kilo ohm, as we have calculated in previous step. Current I3 will be equal to potential difference across this 6 kilo ohm resistance. Voltage across this 6 kilo ohm resistance will be equal to the potential difference of these two voltages, V2 and 12 volt. Now the direction of current is downward, which is indicating that V2 is on higher potential than 12 volt. So the equation of current I3 will be V2 minus 12 volt divided by 6 kilo ohm. Similarly, current I4 will be equal to the potential difference of these two node voltages divided by the value of resistance, V2 minus V3 divided by 2 kilo ohm. Now, in order to solve this equation, we will multiply this equation on both sides with 6 kilo ohm. 6 kilo ohm in denominator will cancel out with the product of 6 kilo ohm. Only V1 minus V2 will left, and same case will be here, only V2 minus 12 volt will left. Here product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator, 3 will left, and that 3 will multiply with V2 minus V3. Now open these brackets, this minus will multiply with variables inside the brackets. Same case will be here, minus 3 will be multiplied with variables inside the brackets. The equation will become V1 minus V2 plus 12 volt minus 3V2 plus 3V3 equal to 0. Now we will place this plus 12 volt on the other hand side of equal to separate it from variables and add all same variables together. The equation will become V1 minus 5V2 plus 3V3 equal to minus 12 volt. And this equation cannot be further solved, so we will label this equation as equation B. It is the second node voltage equation of this network. We will move towards the last non-reference node of the network. On this node, two currents are entering. One is 2 milliampere and other one is I4. Only one current is leaving. Leaving current is taken with negative sign. Now we have to replace these two currents with their respective equations. Current I4 is equal to V2 minus V3 divided by 2 kilo ohm. Similarly, current I5 is equal to V3 divided by 1 kilo ohm. Modify the equation. Now in order to solve this equation, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only V2 minus V3 will left. Product of 2 kilo ohm and 2 milliampere will result 4 volt. Similarly, product of 2 kilo ohm and 1 kilo ohm in denominator will result 2. That 2 will be multiplied with V3. So the equation will become V2 minus V3 plus 4 volt minus 2 V3. Now we will arrange this equation. Place this constant on the other hand side of equal and add minus 2V3 and minus V3 together. The equation will become V2 minus 3V3 equal to minus 4 volt, and it is the third node voltage equation of this network. Up to this point, we have retrieved 3 node voltage equations of this network. Now we will solve these equations to get the value of voltage V3, because this voltage is appearing across 1 kilo ohm resistance and V0 is also appearing across 1 kilo ohm resistance. In other words, V3 will be equal to V0, and it is required to calculate the value of V0 in this network. So first of all, we will multiply this equation B with 3. The resulting equation will be 3V1 minus 15V2 plus 9V3 equal to minus 36 volt. Now we will add this resulting equation with equation A. This plus 3V1 and minus 3V1 will cancel out with each other. Plus V2 and minus 15V2 will result minus 14V2 plus 9V3 equal to minus 72 volt. Now we have another equation minus 14V2 plus 9V3 equal to minus 72 volt. Now in order to calculate the value of voltage V3, we will multiply this equation C with 14 and add that resulting equation into this equation. So the product of 14 with this equation C will become 14V2 minus 42V3 equal to minus 56 volt. Now we will add these both equations together. Minus 14V2 and plus 14V2 will cancel out with each other. Sum of minus 42V3 and plus 9V3 will become minus 33V3 equal to sum of minus 56 volt and minus 72 volt will become 128 volt. In order to get the value of voltage V3, we will divide this equation on both sides with minus 33. The value of voltage V3 will become 3.8787 volt. And actually this voltage V3 is equal to V0, so we can say that the value of voltage V0 inside this network will be 3.88 volt. So this was chapter 3 learning assessment E3.8. Thank you. See you again in next video.